had a great semester. Thank you for that. This is going to be basically semester review, what we have covered. Some of the topic I'm going to talk about, except for the friction, because I have a bunch of video on that one. So this is where we went over the class, and let's go over this, and hope you like this video. If you have not subscribed, subscribe, and if you like it, give the thumbs up. All right, let's get to work. First problem is a vector. We want to find out what is the resultant force of all these four forces combined, and what is the direction. Is it going this way, that way, and what is the angle? So one of the things we got to look at it, each one of these forces, because they are in an angle, they have a component of a horizontal component, x component, and they have a y component. So if you look at this 500, I have a x component and has a y component. What I'm going to do, I'm going to take all the x component of each individual, add them up, take all the y component of the individual and add them up, and then we're going to use Pythagorean theorem, find f of r. All right, let's get to work. First, I'm going to do summation of all f of x is equal, going to the right is positive. So I'm going to have 500, and the x component of this is going to be cosine 45. And that's going to the right. And this one also going to the right, so it's going to be positive. And it's going to be 470 cosine 25. And next one is going to be going the other way, so it's going to be negative. It's going to be minus 300. Minus 300. That'd be sine 26. And finally, minus, this one is going that way. It's going to be 200 sine 35. So our f of x comes out to be almost 533 pounds, and it's going to the right. That's the direction. Let's do the same thing, doing it in a y direction. So I'm going to take the y component of each one of these individual, and I'm going to add them up. So I'm going to say, okay, summation f of y is equal, going up is positive, this is going up, so that's going to be 500 sine 45, and that's a vertical component of it. And then I'm going to have that's going down, so it's going to be minus 470 sine 25. And then this one is still going down, minus 300, and that's going to be cosine 26. And then I'm going to have going up plus 200 cosine 35, which is equal, I have 49 pound, and that's going up. So I know you learned this at the beginning of the semester. If I want an x component of this, I'm just going to close it with cosine. If I want to go the other way, if I have this angle, I'm going to do the y component with sine. You know that stuff. Now, Pythagorean theorem, it says, you know, we can go ahead and find resultant force, which is equal square root of f of x squared plus f of y squared, and that's equal. This doesn't come out right. Let me change color on you. And that's going to come out to 533 squared plus 49 squared, and that comes out approximately to 535. Double check my number. This is what we had in class anyway. So this 535. What does it mean by 535? Let's do this first. If I'm going to go ahead and make a my x came out, let's go like this for now. Okay. And x came out to be 533. So it's going to be 533 like this, okay? 533, positive. Y came out 49 positive, so it's going to be 49 positive right here. So that's 49. I'm going to square this up like this, and then the resultant force is going to be from this tip to tip here right here. That's my resultant force, which came out to be 535. But what is this angle right there? So that angle is going to be theta equal tangent inverse of opposite, which is right here, divided by Jason, which is 49 divided by 533. 49 divided by 533, and I think we got this come out to be 5.3 degree. That's it. So this is one problem. Question, we have a beam here. We like to find the beam reaction. The beam reaction are here, and this end is pinned. This end is a roller. Roller means basically there is one restriction in a y direction, so that's going to be, if this is a B, so this is going to be by, and if this is a A, and that's a pin, I mean there's two forces here restricted, AY and AX. So it's kind of pinned like this, pinned. It cannot go up and down, that's why it's right there, and it cannot go this way, so you have the X restriction. We like to find the reaction, but our uniform distributed load is in an odd shape. We like to convert that to a concentrated load. How we do that? So I'm going to make this load to equal to one load. Because this is a triangle, the area of triangle is what? It's 1/2 of the base times the height, or whatever way we look at it. So let's find this, convert this all uniform distributed load, replace them with one load. And let's put the load right here for now. And that's going to be 1/2 450 times 9. That's equal, so you have it here, 2025. This is a good year. Just the year we are in, 2025. So that's going to be pound. And this is already converted to 700 pounds. We don't have to do anything. Now here I got a different shape. I can only deal with the triangle, or I can only deal with rectangular. But I can make this shape to two different shapes. Let's make a triangle out of it and make a rectangle out of it. What happens if I go ahead and make a straight line from here? So I make a triangle on the top part. Okay, right there. So now I got a triangle. Just look at the focus on the top part. So it's kind of like this, basically. All right. And what is this width? If this is a 400 and that's a 200, 200 minus 400, so that becomes 200. All right. So my triangle is 200 by 12. Just looking at the top part. I'm not looking at here. Okay. Look it up here. So therefore, I'm going to replace this part top here with one load, and I'm going to put the load right here. Okay, and the magnitude of that load is going to be area of this triangle. So it's 1/2. It's only 200. Do I have a room? Yeah, 200 times 12. So that's basically is 1,200, right? 1,200 pound. Okay. What is that? The center of, so these two load, it's going to be at the center of the triangle. Center of a triangle is 1/3 from the base. So 1/3 of 9 right here become 3 feet. And 1/3 of 12 become 4 feet. So they become 4 feet from here. Okay. Now let's deal with this portion itself, this rectangular portion. Let me use a different color here. And the center of the rectangular is, if this is 12, it's going to be 6 feet. So it's going to be right here. So I'm going to replace this one with one load right there. And that's going to be the area of this rectangular, which is a 200 by 12. 200 times 12. And that's equal, we got 2,400. All right. That's it. You're basically done. So now when you look at this whole thing, ignore all these arrows. Just these 3 arrows you have. You got this one right here, this one right here, this one right here, and these 2. So if I really had to go ahead and do this, it'd be like this. I got one load right there, I got one load right here, I got one load right here, and I got one load right here. and this came out to 1200. This came out to 2400. This was given 700. This came out to be 2025, and we already know the distance. So now I want to go ahead and find the reaction force. This is our sign convention. Going up is positive, going right is positive, counterclockwise moment is positive. We talked about this 1,000 times. So I want to find out these three unknown equations. I can take a moment about here or here, doesn't matter. If I take a moment about here, I go from this side. If I take a moment about there, I start from this side. That's how I do things. So let's go ahead and take a moment about point A. So we can start from this side. Summation moment about point A is equal 0. Counterclockwise is positive. So the first force I have is By. By is going to go up and rotate. You see that? Clockwise. Rotate counterclockwise, so it's positive. So it's going to be By time, and this is a 9. Let me turn this on here. So we got 9 times 9 and 5 is 14. 14, 24, 26. So that's going to be time 26. Okay, and then next force we have is right here. It's a 2025, and that's going to rotate clockwise, so it's minus 20, 25 time, and that's 26 minus 3 be 23. Okay, and then the next one is minus 700, and that's going to be 3 and 12 is 15. And the next one is going to be this one right here, 2400 minus 2400 time 6, and minus 1200 time 4 equals 0, and we're going to get our By come down to B. Okay, 3.7, and it's going up, and that's a pound. So that's By. And let's go ahead and do, we can use one of the other equations. Summation f of y is equal 0. Going up is positive. I have 3.7 minus 2025 minus 700 minus 2400 minus 1200, and that's equal 3391.3 pound. All right, so we got that, and the next one is the summation f of x, this one, which is no x direction. Summation f of x is equal 0. Going right is positive. Therefore, ax is equal 0. That's it. So that's one problem. All right, let me erase this. We're going to go to another one. Truss. Let me put it up on the board right there. So we got 6 bay at 120, at 20, which is coming to 120 feet, from A to G. And you have all those load on top from 10, 20, 30 back to 20 and 10. And the height of the truss is 15 feet. And then we have pin and a roller, so GY and AX and AY. The first thing we're going to do, we're going to go ahead and calculate the reaction, the whole thing as a one rigid body. And then we're going to go ahead and use the method of adjoint to calculate the member force in member AL, AB, and LB. So let's get to work. And one of the things we're going to do first is going to take a moment about point A. So I'm going to go ahead right here. Summation moment about point A is equal to 0. Counterclockwise is positive. Start from one end to the other end. We're going to have GY time 120. And start from left to the right. And that's going to counterclockwise, so it's going to be positive. then it's going to be the first load on top, 15 times 15 plus 15 times 15, and that's a counterclockwise also. And all the vertical load right here, all the vertical load, it's going to be coming down at clockwise, so it's going to be negative. So it's going to be minus 10 times 100, and minus 20 times 80, and minus 30 times 60. Continue with that, it'd be minus 20 times 40, and minus 10 times 20. And that's equals 0. So GY is 43.125, so just say 12. And that's going to be being up. And these are KIP, so let's say that's what it is. The next thing we're going to calculate is summation f of y. I want to find out what AY is. And I'm going to have 43.12 minus 10, 20, 30, 20, 10. Minus 10, minus 20, minus 30, minus 20, minus 10. I think I got it right. 10, 20, 20, 30, 30. And then we have the AY. Plus AY, and that's equal 0. So AY comes out to be 46.9 pound. Okay, that's good. That's good. Now, okay, we have one more. That's summation f of x, excuse me, is equal 0. Going right is positive. We have 15 KIP and AX. So AX minus 15 is equal 0, and therefore AX is equal 15 KIPs, and that's going to the right. Now we're going to use a summation. I'm going to use a method of joint to figure this out. If I look at just corner part of that truss, it's going to be like this. Just the corner of it. I'm not going to do the rest of it. And down here we have 10 KIP coming down. And then this is a L. That's a B. That's A right here. And we had this forces coming in, which was 15 and 46.9. So 46.9 and 15. Then I have this member and this member. So if I focus on joint A, I only have this, this, this. So I'm going to bring joint A over here. This is joint A, all right? And I'm going to put all those forces back into it. I'm going to have this member right there. I'm have this member right there, and that's going to be F of BA or AB. And this is going to be F of AL. Let's call this F of AL. And then I have the reaction right here, which was 46.9 and 15. Okay? I don't know if this is tension or compression. I always say top is in compression, bottom is in tension. So if a bottom is in tension, that means it's going away. If top is in compression, that means it's coming into it. So let's just leave it like that. But I want to know what is this angle, or what is this thing is. So in here, let me look at my truss again. In here we had 15, and this is 20. So if I divide 15 by 5, that's equal 3. Divide by 5 is equal 3. Divide by 5 is equal 4. So that becomes 3, 4, 5. Or I can just find the angle. Doesn't matter. So I'm going to come in here. I'm going to say, oh, that's a 3, 4, 5. Again, when we do a truss by joint method, we only have two equations. These two right there. Summation of x, summation of y. So if I use summation f of x, this is one unknown, two unknown. I cannot do it. But if I use summation of f of y, I have only one unknown. So let's go with summation f of y. summation f of y is equal 0 for this particular joint. I'm going to have 46.9 minus FAL. Okay, FAL has a horizontal component and has a vertical component, so it has two components. The vertical component is going to be FAL multiplied by 3 divided by 5. This is a vertical, 3 divided by 5. So 3 divided by 5 equals 0, and FAL comes out to be 0.2. And because my number came out positive, therefore this is going to be in kip, but it's going to be in compression. All right, let's do the summation of fx is equal to 0. Going right is positive. I have FAB plus 15 minus, this came out to 78.2, and the horizontal component of it is going to be 4 over 5 times 4 over 5 equals 0, and FAB comes out to be, and that's going to become a positive number, 47.6 in its intention. Kip intention. Just made the screen. Okay, so that we found this. Now we're gonna find this. In order to find this, either I gotta go over there or over here. So let's go over here. Point L. I can do it right here. So let me change color. Point L is right there. All right, and we have this 10 coming down, and if you look at the whole truss, there's a member coming this way, so that's going to be one right here, and that's top in compression. That's a F of LK, and then I'm going to have this coming down here. We already figured it out. That was a 78.2 in compression, which is compression 3, 4, 5, 3, 4, 5, and then we have I think there's one coming down this way, and that's one we're looking for, FLB. So I'm going to assume it's tension. Okay, I could be wrong. Let's figure it out. So if I do summation f of y, this is known, this is known, this is known. I mean, this is unknown, so we can do summation of y. That's all we need to do. Summation f of y is equal to 0. Going up is positive. I have f minus FLB. Okay, minus 10. This is a 10, not 16. Okay, and plus 78.2. Vertical component is going to be 3 over 5. 3 over 5 equals 0, and therefore FLK comes out to be FLB, sorry. FLB comes out to be, oh, it's positive, 36.9. So FLB is equal to 36.9 in tension. And that's kip. Do I have room? Yep, perfect. All right, so this is, we used method of joint to figure this out. We're going to continue this problem, same problem, but we're going to use method of a section. Okay, and here we have the same truss, but we're looking for this member, this member, this member. So we took the truss and we cut it in half where we're looking for those members. So we're going to cut it in half right here, as we've shown over there. Once I make a cut, I replace my cut with forces. So let's go ahead and say we knew the reaction. We had two reactions here. AY came out to be 47, and AX came out to be 15, and we have these loads up here. Now up here, I'm going to replace this member, and this member with the force. And we said the top number is a compression. Because it's a compression, I'm going to replace it with like this with it. Okay? And that's going to be f of ji. And then bottom is a tension. So we're going to replace them with tension. And we're going to say that's f of dE. And here we can guess either it's compression or tension. Let's say it's compression because you can go tension, doesn't matter. Let's go say compression. Okay, so it's compression also. We're going to replace them with that, and that's a f of je. Okay, you gotta do this to solve this problem. We already know the reaction force, so we cut the whole truss in half. Where we cut it, we're gonna replace this with these three forces, and then we're gonna analyze these forces. That's it. There's nothing to it. You need this free body diagram to solve it. Okay, now I have this, this, this. I have 1 unknown, 2 unknown, 3 unknown. I have all those 3 equations. I can solve it. If I take a moment about this point, I eliminate this, this, because this line of action. If I take a moment about this point, I eliminate this too. It's a line of action. Doesn't matter. Your choice. You can do which way you want it. All right, and we also know that this is a 3, 4, 5 angle. And let's take a moment about point E. Summation moment about point E is equal 0. Counterclockwise is positive. I'm going to start from this end, and it's going to be minus 47. Minus 47 times, this is 20, this is 20, this is 20, that's another 20, so that's 80. This cannot take a moment about here. It's the same line of action. So this is going to go ahead and go counterclockwise. Plus 10 times 60 plus 20 times 40 plus 30 times 20. And then this cannot take a moment. This cannot take a moment, so it's this one. This one's going to come out, and it's going to go, see, it's going to go counterclockwise. So it's going to be plus f of ji times 15 equals 0. And f of ji comes out to be okay, came out positive, 117. I think those are kips anyway, so kips in compression. That's it. So this problem is already solved. Now we got this. I can use summation f of y and summation f of x to solve rest of them. Summation f of y is equal to 0. Going up is positive. I have 47 positive, minus 10, minus 20, minus 30. That's only what I got. Plus f of je, and the vertical component is a 3 over 5. Equals 0. Let's say this number comes out positive. F of je comes out to be, check my number, I got 21.7. And it's pure compression because it came out positive. All right, the next thing I'm going to do is summation f of x is equal to 0, and f of x I have 15. I have plus f of dE. That's it. That's how it is. Nothing to it. The hardest part is to get this right. Nothing to it. Just cut it, and then when you cut it, replace all those numbers with the forces. This bottom is tension, part is compression. You don't know, put the arrow. If the number came out negative, you just go ahead, switch your arrow, and that's, you know, you made a wrong assumption. That's it. All right, let me erase this board. We're going to do our last problem. Okay, so we have this problem right here. Want to know what is the moment inertia about x. When you do moment inertia, first you got to find the neutral axis or centroid of the shape. We know this is symmetric. This side is equal that way, so IY, or compared to the AX, is all symmetric. We're not going to worry about that. But we'd like to know where is the Y bar is in this way. So we're looking for this line right here. how far is this center of this shape is this way. First thing you do, you're going to divide them by shape, but you always got to have a reference point. I'm going to measure everything from bottom here. See right here? I'm going to measure everything from bottom here. Let's just call this x prime, x prime. Measure everything from here up. So I'm going to call this rectangular shape right there, shape number 1. All right? Then I got 2 triangles. If I can do this, you know, and I can do this. So now I got 2 triangles. Let's call this shape number 2, also shape number 2. And then from here down, all the way to here, let's call this shape number 3. So I got 3 shapes, 2, 2, 1, and 3. And first thing I'm going to do, I'm going to find out this y bar right here. So this distance right here is a big y bar I'm looking for. Y bar is equal, let's figure it out. I'm going to come up here, and I'm going to say shape number 1. The area of shape number 1 is 3 times 28, and 3 times 28 is 84. Okay, so what is the y bar of shape number 1? Center of shape number 1 is right here, and that's about right here. It's about 1.5 inch. If this is a 3, half would be 1.5. So from here to here is what? I got 16 to here plus 4 is 20. So from all the way here to here is 20 inches. So I got 20 plus 1.5, so it makes it 21.5. So this is a 21.5. A times y, we already did this in class. I have them right here. Remember, we did this together. So I'm going to go ahead and put this number back in here. And a times y came out to be 1806. Let's go to shape number 2. Shape number 2 is, I've got 2 of them, so I'm going to write down twice. This one and that one. And area of shape number 2 is a triangle. So it's going to be A2 is equal 1/2. This is 4 inches, that's 4 inches. So we got a triangle like this. It's like that. Okay, it's 4 inch tall and 4 inch wide. So area is a 4 times 4, 16 divided by 2, and that gives me 8. So area is 8. Y bar. Now remember, we talked about the triangle. The center of the triangle is a 1/3 from the base, so it's 1/3 right here. And that is, if this is a 4 inch, that's 1/3 of 4, which is equal 4 divided by 3. So that's a 4 divided by 3. From here to here is a 20. So 20 minus 4 divided by 3, and that will give me 18.67. 18.67. 18.67. If I multiply that by 8, I should get 149.4. 149.4. 149.4. Shape number 3. Shape number 3, we have 20 inch by 6 inch, so it's 120. And the middle of this is a 10 inch, and 10 times 20 is 1200. So let's add all this up. Let's say summation of all a times b got the 220, and a times y comes out to be 3305. And we know the big y bar is going to be summation of ay divided by the summation of a. And that is equal 3305 divided by 220. I think that comes out to 15. Yes, it did. So that's equal 15. And right here we have 15. Now we have that, we can find d. D is a distance. Okay, pay attention. D is a distance between individual shape and the center of the entire shape. So center of the shape 1, from here, it was 21.5. Center of the entire shape is 15. So I'm going to say D1 is equal 21.5 minus 15, and that will give me 6.5. 6.5, and square that, multiply by a, and that comes out to 35.49. Okay. We'll come back and do the I later. Let's just finish this part. And shape number 2, D2, R2D2 is equal, the center of shape number 2 was 1867 minus 15, and that will give us 3.67. So I got 3.67, 3.67, and if I square those and multiply, it become 108 each. 108. Finally, the last shape, 10 minus 15, that's a 5. And 5 times that, it become 3,000. All right, let's do the moment inertia. I want to come in here, show you something. The moment inertia for rectangular or square shape is 112 bh cubed, and this is a h, that's a b. For triangle, okay, this will be the h, this will be the b, is 1 over 36 bh cubed. All right, so now we're going to find IO. IO, first one is I1. I1 is equal 112. B is a 28. And H is a 3 by power 3, and that's equal 63. So I got 63 inch by power 4. So that's an inch by power 4. And the triangle one is I2 is 1 over 36. B is a 4 inch. H is a 4 inch by power 3. And that comes out to be 7.1 inch by power 4. So I got 7.1, 7.1. Finally, I got the big one, which is I3. Let me write down here. No, I3. And that's equal 112 6 times 20 cubed. And that will give us 4,000. So I'm going to come down here, write down 4,000. I'm going to do all AD squared, and I'm going to do H squared. The AD squared came out to be 6764, and individual moment inertia came out to be 4077. Now, the compound shape of moment inertia for total moment inertia for compound shape I is equal summation of IO plus and summation of AD squared, and it's going to be 6764 plus 4077. So IX comes out to be 10842. Whoops. That's the answer. Inch by power 4. All right, that's it. If you made it this far, thumbs up for you. Good luck. Thank you for a good semester.